welcome back to Kochu's channels. Today we are discussing the topic about the electrochemistry. What is the electrochemistry or what is the electrochemical cell? What is the electrochemical cell? A device that converts the chemical energy to electrical energy is known as electrochemical cell or the galvanic cell. What is the example? Yes, the Daniel cell is the example. Okay, figure we can see the zinc rod is dipped in the zinc sulfate solution and copper rod is dipped in the copper sulfate solution. The two rods are connected by a wire and through the voltmeter. The two solutions are connected by salt bridge. Okay, then the electric current flows through the electric circuit. And what is the reaction of the Daniel cell? What is the reaction? Yes, zinc 2 gives zinc 2 plus 2 electron. That is, the 2 electrons are removing. And the oxidation state of the zinc, which can change us from 0 to 2 plus. Okay, then similarly, the copper 2 plus 2 electron 2 gives copper. That is, 2 plus oxidation state which reduced to 0. That is its reduction. Okay, that is the what is the overall reaction? Zinc plus copper 2 plus 2 gives zinc 2 plus copper. That is the redox process. That is reduction and oxidation while we getting the same reaction and is known as or same one step reaction is known as redox process. Okay, the electrode at which the oxidation takes place is anode and at which the reduction occurs is called cathode. So, the zinc acts as a anode and copper acts as a cathode. Okay. Next, what is the representation of a electrochemical cell? What is representation? An electrochemical cell is represented as the anode bar anode electrolyte salt bridge cathode electrolyte bar cathode. Here, zinc as an anode and anode electrolyte as a zinc sulfate solution. That is the zinc in the zinc 2 plus ions. And the cathode electrolyte solution, copper is present in the copper 2 plus and cathode is copper. Okay, what is the cell representation? What is the cell representation? Zinc bar zinc 2 plus bar. That means it's a salt bridge and copper 2 plus bar copper. Okay. Then what is the electrode potential and cell potential? The potential difference between the metal and its ion solution is known as the half cell potential or electrode potential, which represented by E0 cell. Okay, that is E cell is equal to E cathode minus E anode. E cell is the difference between the electrode potential of the two half cell reaction is known as cell potential. Okay, that is E cell. Again, E cell is equal to E cathode minus E anode. Okay, then next is the She. What is the full name of She? She is the standard hydrogen electrode or the normal hydrogen electrode. It consists of the platinum wire sealed into glass tube and carrying a platinum foil at one end. The electrode is placed in aqueous acid solution containing the 1 molar H plus ions. That is the H plus may be any acids. Okay. Then the pure hydrogen gas at 1 bar pressure is bubbled through the solution at 298 Kelvin. The electrode potential of She is taken as 0. That is the E. That means the E cell value of the She is equal to 0. E cell value of the She is equal to 0. What is the use of She? Measurement of the electrode potential. How? To determine the potential of the electrode, it is coupled with the She to form the cell. Okay, the EMF of the cell is determined by using potentiometer. Since one of the electrode is involved is She is having the 0 potential and the measured EMF will be numerically equal to the potential of the electrode. Okay. What is the electrochemical series? The arrangement of atoms or the arrangements of the elements in the order of the standard reduction potential is called the electrochemical series or the activity series. What are their application? To compare the relative reactivity of the metals, okay, and to compare the relative oxidizing and reducing ability, to construct the electrochemical cells and the calculate their standard EMF. These are the main three application of the electrochemical series. What is the usage or what is the Nernst equation? Nernst equation provides a quantitative relationship between the concentration of the electrolyte solution used in the electrode and electrode potential. General representation, that means the Mn plus an electron to gives M, that is which is the metal in the oxidation state is N plus, and it's reduced form M, that is oxidation state of the metal, that in the M is equal to 0, that is the electrode is equal to E0 electrode minus RT by NF ln M molar concentration of M, that means the product by molar concentration of the reactant. For substituting the values of universal gas constant, R is equal to 8.314 and F is equal to 96500 Coulomb and temperature is equal to 298 Kelvin, and the reaction and the equation will become the logarithmic. We get the Mn plus bar M2 gives E0 Mn plus bar M minus 0.059 by n log 1 by molar concentration of Mn plus. What is the why we get the 1? That means the molar concentration of the product which is equal to 1. Okay, then the general representation or the in the form of the zinc and copper reaction, that is E cell is equal to E0 cell minus 0.059 by 2 log molar concentration of sudden 2 plus bar molar concentration of copper 2 plus at 298 Kelvin, where the N is equal to 2, that is the number of electrons passing through this electrochemical reaction is equal to 2, so the N is equal to 2. Okay, then what is the equilibrium constant from the Nernst equation? That is E0 cell is equal to 0.059 by N log Kc, where Kc is the equilibrium constant. Okay, Gibbs free energy and the cell potential. Delta G0 is equal to minus NF E0. That is, N is the number of electrons and F is the Faraday and E0 cell is the standard electrode potential. And what is the relationship between the Gibbs free energy and the equilibrium constant? That is, delta G0 is equal to minus 2.303 RT log Kc. Kc, that is Kc be the equilibrium constant. Okay. What is the or what are the main factors affecting the conductivity of the electrolyte solution? First one is the nature of the electrolyte, whether it is the strong electrolyte ions and move easily, and the next number 2 is the size of the ion produced and their solvation, and number 3 the nature of the solvent and its viscosity, and number 4 is the concentration of the electrolyte, and number 5 is the temperature. Next is the molar conductivity. Molar conductivity or lambda M of an electrolyte solution at a given concentration is the conductance of all the ions formed from 1 mole of the electrolyte kept between the two electrolytes at a distance of the unit length. Okay, then the lambda M general representation is equal to 1000 K by M, where M is the molarity of the solution. And what is the limiting molar conductivity or limiting value? The limiting value of the molar conductivity when the concentration approaches the 0 and is called the limiting molar conductivity or the molar conductivity at the infinite solution, and is Coleridge's law of the independent migrations of ions. This law states that the limiting molar conductivity of the electrolyte is the sum of the limiting molar ionic conductivity of the cations and the anions of the electrolyte present in the solution. That is the limiting molar conductivity, which is equal to or the one example. For example, one formula of unit of aluminum sulfate gives the 2 aluminum ions and the 3 sulfate ions. Then we can represent the limiting molar conductivity of the aluminum sulfate, which is equal to 2 limiting molar conductivity for aluminum 3 plus 3 of limiting molar conductivity of sulfate ions. Okay. Next, what is the application? Application to calculate the limiting molar conductivity of the weak electrolyte and to calculate the degree of dissociation of the or dissociation constant of the weak electrolyte. Okay. Next is the batteries. Batteries, the stands of the arrangements of the 2 or more galvanic cells. And these are mainly 2 types, the primary and secondary. Okay, what is the primary? For example, the primary is the dry cell. Okay. Dry cell is a compact version of the Lagrange cell and it consists of the cylindrical zinc container acting as an anode. A graphite rod at the center of not touching the base of the container acts as a cathode. The graphite rod has a brass cap for better electrical contact and it's surrounded by the pounded manganese dioxide and the calcium powder. Okay, the space between the electrodes is filled with a paste of ammonium chloride and zinc chloride. What is the reaction? Zinc undergoes the oxidation and manganese dioxide under the reduction. That is the cathode. Next is the lead storage battery act as a secondary cell. And it consists of the lead anode and made of the spongy lead and grid of the lead packed with lead dioxide acting as a cathode. Sulfuric acid is used as a electrolyte and the reaction is take place. The lead undergo the oxidation and lead dioxide undergo the reduction and the overall reaction is equal to lead plus lead dioxide plus 2 molecules of sulfuric acid to gives lead sulfate plus 2H2O. Next is the fuel cell. There are devices which converts the energy produced by the combustion of the fuel directly into the electrical energy. For example, H2O2 fuel cells consist of the porous carbon electrode containing the suitable catalyst like the platinum or palladium, and the H2 and the O2 are bubbled through the porous electrode into the aqueous NaOH or the KOH. The following reaction take place. What are the following reactions? At anode, H2 is undergo the oxidation and at cathode, oxygen undergo the reduction. Okay, what is the overall reaction? 2H2O plus O2 to gives 2H2O. What are the main application or what are the main advantage of the fuel cell? First one is the fuel cells have the long life, and second one is they are high efficient, and third one is the fuel cells are the pollution free. These are the 3 points. Students, please note. Okay, next last topic of our chapter, that is the corrosion. What is the corrosion? Corrosion is the slow destruction of the metals due to the attack of the atmosphere gases and the moisture on their surface, resulting in the formation of the compound such as oxide, sulfide, carbonate, etc. And it's the corrosion. And what are the examples? Rusting of iron and tarnishing of silver, and it's also developing a green color of the coating of. Okay, then what is the electrochemical theory of the corrosion? What is the electrochemistry? At anode, the iron undergo the oxidation, that is the removal of electron, and it's undergo the 0 to 2 plus oxidation state. At a cathode, 4H plus ions undergo the reduction to forms 2H2O. Okay, then what is the rust? What is the rust of the reaction? That is, students, please note, what is the rust? Fe2O3 dot H2O. It is the rust. Okay. Last topic is the prevention of the corrosion. One is the sacrificial protection and other is the barrier protection and last is the cathodic protection. Okay, thank you.